Hi there, welcome to Tech Date. Let's dive into our today's problem, minimum size subarray sum. So it says you will be given an array of positive integer nums and a positive integer target. We need to return the minimum length of subarray whose sum is greater than or equal to target. If there is no such subarray, we can just return 0. So let's just look at this test case. So this is a given array and the target is 7. So I need to find the sum of elements, right, that in that subarray. So let's start with this 2. It's less than 2, 7. 5, 6, 7, 8. So these are the four elements and the subarray is valid. So now I can calculate the size, right? So that will be 4 here. Now if I just include one more, since it's an array of positive integers, that means all the elements after that will result in a sum of greater than equal to 7, so all of the corresponding ranges will be valid. But we're just interested in minimum, so this is my first valid range. So what I can do, if I just exclude the 2 from here, I can check whether 3, 1, 2 are still valid, so that I can arrive at smaller window, because I need to find the minimum, right? So there's no point of evaluating this window, because we already know at this point the sum was 8. It's always going to be greater than 8, because the numbers are positive. So I can just exclude this. I can see if my window is still valid, otherwise I can keep on increasing the size. So I can still check it's still valid. Now it's still 4. Now I can again exclude the left one, and I can check if it's valid. Now it's valid, and size is 3. So we got a better window. And then I can again traverse through it. Size is still 4, we didn't get. Then 2 and 4, and then 4 and 3. Size is still valid, window is valid, so size is 2. That will be a minimum. So let's just traverse through it. So it will be, let's say, int sum is equal to 0 initially, and then we can say my left pointer, let's just call it 0, and let's initialize a right pointer, right less than nums dot length, right plus plus. We'll just calculate the sum of this right elements, and if we arrive at some window which is greater than equal to the target, we can say I need to calculate the size of this window, and I need to track of minimum out of it. So the minimum of the size of the elements, which will be this number of elements. And then I can say I have arrived at the window. Does my window have a shorter window? If I just squeeze this window, reduce the element to 1, subtract one element from it, from the left hand side, do I left with a valid window? And let's just increment this left pointer. So I need to keep on triggering this unless we arrive at an invalid window. So till my sum is greater than equal to target, I'll keep on squeezing the window, and then this should be fine. We need to keep track of minimum. Let's just declare that variable. So here we'll have length till 10 raised to power 5. So let's just use that upper bound, maybe just plus 1, so that we can eliminate any edge cases. So here we can say, but there could be a case when we never reach the target, right? Even with all the numbers are exhausted, that means my maximum will always be this value. It will never be redefined. So we'll just return 0, otherwise whatever the minimum that they have computed. So let's just try to run this. Okay, it's called nums. Yep, this looks like it's accepted. Let's just submit. Okay, it beats 100%. That is perfect. So this is like again the sliding window approach. We'll check if our window is valid. We'll try to squeeze it down, and we'll maintain this left right pointers. Keep the edge cases in mind. So if the sum could never be reached, we can just have that condition and check. There's one more optimization when maybe we can do, like, if minimum is 1. So if we have found an element that is already exist there, so we can just return. We don't need to traverse the other end of the array. So we can return minimum itself. So if we submit this, yeah, again it's accepted. So yeah, thank you.